Guys will actually try to, like, we try to give as much credit as possible, so occasionally you'll see dots and you're not sure whether they're actually, you know, so yeah, so tell your kids to be real careful about making it clear, but I would always rather give the point than not give the point if I saw a stray thing that looked like it might possibly be a dot, so.
And sulfurs have to be in the middle on that.
Yes, sulfurs have to be formal charge, the sulfurs in the middle center there.
So for this, you're talking about the whole 0.49 versus 0.51. What room for error is there coming from?
I don't, in this one, I don't think so.
It's
I don't
either right
think
or wrong.
yeah, it's either correct structure or it's not.
They provided the outline CL,
Yes.
CLFS.
The order.
Yeah,
That's
they
right.
provided that.
That's right.
That makes
So,
sense.
yeah, okay.
So it wasn't like we're gonna try to put the chlorine together.
Are you guys all good with this, Louis? I know that some of you don't agree with the rubric, and like I said, I don't necessarily either, but, and I used to teach connect the dots. It worked pretty well for simple structures, and then you get to more complicated, and you change it up a little bit, but no dots connected, no dots. So then part 2 there is the bond angle, right? Now I happen to like the fact that they allow for a range. Notice it says any value between 104 and 110. Now we know it's probably going to be what? 104 and a half-ish, somewhere in there. 105 would be the bond angle. So guys, notice there on part 2 of letter C, we're taking, so they could write 104.9 or 936, and they'd get credit for that. Some stupid, you know what I mean? Some dumb, as long as it's in that range somewhere. Most kids will do 109 and a half, by the way. Maybe 107 you might get, with the ammonia, and then 104 and a half is probably a fairly common. So 104 to 110, including the 2 M's. Right? So any of those.
So really here, I'm
Say-
sorry.
no, that's okay.
So here with that answer, they're really emphasizing what the lone pairs do to the
Best
bond
for-
angle versus they're not all about memorizing these particular things. It's about the trend of what happens to the angle. More
I
so.
told my students to focus all the bond angles around 180, 120, and 109.5 and think like those specifically or less than those 3. And so in this question, they would also take like less than 109.5 because that's going to fall in that 104 to 110. So yeah, they're really trying really hard to get rid of all this memorizing crap that used to be so prolific in this class. What's that?
Required for chemistry.
Yeah, I mean, there is some stuff you gotta memorize, but I think they're really trying to test your ability to do stuff rather than your ability to memorize stuff.
So so Gen Chem, if they memorize a couple of the angles and then you tell them in AP, okay, now we focus on what's actually happening. What's this trend more so?
Yeah, and add some more shapes. There's T-shaped. I don't do T-shaped or seesaw or any of those in my honors class. I wait until AP. I just stick to the 5 basic. I figure they got enough, with those 5 basic.
So they don't seem to care at all that the kids are supposed to know that those lone pairs push it to be less than, because they would accept.
Okay, so let's take this first paper, right? And you have it on your laptop, and then you also have the hard copy of the rubric. So the 2 of you together, so find a buddy somewhere, the 2 of you together, if you could score it together and see if you can come to a consensus about the overall score. And guys, we're only doing just 1A, all right? Just that first paper. Does that make sense?
Yeah, I think both of them.
You can join them.
She doesn't have access.
Oh, but she does.
So we're on number 1.
There's an open one there.
Oh, yeah. It's already memory on low battery. This way, and I gave it 3 or 4. Okay, why
did they give them that? Yeah, because they took their answer from a file. No, just there.
I didn't give a point. That's what I was.
Yeah, we were looking at that.
I see that. So we're in full screen.
Yeah, that's weird. How else do you judge that they can literally put any number?
Yeah, that's a higher chance of things, you know, you'll have a higher.
Their graph was
Wait a second, hold on.
I guess if we're doing, if they just multiply two things, they get a point. Because I mean, he doesn't mention it.
So they assign formal charges at the top. Oh, okay, yeah, I was gonna write about that.
So they definitely didn't do the case. See, they want something. They wanted.
I would say this is valid justification, but I'm negative on that.
I would tell the kids to elaborate.
I didn't put all those details in there, but if they want to get into research in the Arrhenius plot, like I said, I labeled it as an extension. It's more kind of like a bonus question.
Yeah, I like how this goes up so many levels from the original, right? And you bumped it up a notch for sure. So Aaron, so you're saying you would use this more like a wraparound thing, potentially, right?
I think that the first activity as written would be a good introductory activity. And then with some more explicit practice with using differential rate law to come up with the orders with respect to the reactants, then you could answer 5 and 6. And then as you go through further, if you have some time at the end of your rate unit before testing and you feel like so this turned into an activity where the last page is almost like you come back to it maybe after another lesson a couple times.
Yeah, this is fantastic. I like all the scaffolding in here.
Yeah, I like the way you can weave it continuously back to the same thing. It just makes it make sense because it's building so much.
Well, and what's cool is all three of you that did the same lab all came up with, pretty much completely different things, which is kind of cool too. You kind of all saw it differently. Yeah, that's awesome. Awesome.
Thank you.
See, we all need to teach in the same school so we can use each other's stuff.
That's what this is all about, right?
Right, that's exactly. That's a fun part. I mean, I don't know about you, Jennifer, but I always leave with stuff. Always. Something.
I always do.
And generally, I take them back and use them too. So who would be next? Did we hear from Rita already? Rita's next? Yes?
Yeah, I can go next if you want.
Okay. And yours was you did take the sodium hydroxide.
Yes, but mine was not detailed. It was quick and easy to the point. I just assigned the pre-lab questions as homework. There is a mini lab that the students mix the calcium chloride and water in a Ziploc bag. I usually assign it as a formative assessment, and the group that keeps the temperature the highest for the longest time will get the highest grade on the formative assessment.
Oh, nice.
Yeah, that's basically.
There's that competition factor in there, right?
Yeah, buy-in.
Yep, that's it.
I like the way you've taken it and broken it up, and you're kind of using the whole thing, but you're using it in different ways in different places. That's nice. The idea of collecting all the data and then putting it back out for the whole group group to use is a great idea as well.
Thank you.
And number 4, when you said, so are you looking at number 4 for the kids to realize that the per mole is going to stay the same, correct?
Exactly. So the mass of sodium hydroxide will not alter the delta H value.
Well, and that's probably better than just saying it, right? To actually have them, yes. And so they would actually do this in lab, correct? They would change.
Yes.
Okay. Yeah, that's a great idea.
Thank you.
Very nice. That was not short and sweet. It just looks short and sweet on paper, but shoot. All right. So who is left?